So we sketch the ellipse in our green plane here. It's going to look like this. Now when I sketch the ellipse, I make sure that the ellipse is tangent to whichever line it's in fact tangent to, so that when I sketch here, the ellipse starts out in this direction, and it's got to come around to be tangent here. So we see that it's got to kind of come around like this. Didn't quite do that right. Here we got to come around tangent to the one side of the rectangle and back to the other, and my pen's kind of in my way here, but no excuse. I'm not a particularly good artist. And then same thing here. We come around like so. And now we have a green ellipse. Now I'm not sure how well those colors show up. And that ellipse is in a plane above the XY plane, and a red ellipse is going to occur in the we're going to sketch a red ellipse in a plane we just constructed that's even a little further above the XY plane. So that we've got a black ellipse, a green ellipse, and I don't think that green really shows as being too much different than the black, and a red ellipse. Now let's think about a time scale. We don't know what this distance is here, but it looks like maybe it's a unit distance. However, we're gonna adjust our scale a little bit because the 9t here would actually, if t equals 1 for this plane, then our sine function and cosine functions would have gone through arguments to go from 0 up to 9. 9 is not a particularly good number to take the sine of. 9 is also a good portion of a revolution around a circle, and that's going to be a little hard to draw. So I'm going to assume that this green plane here is one that takes us a quarter of the way around our ellipse. So that we're going to start here at t equals 0, and we're going to come a quarter of the way around the ellipse here. Now let's see what t is, and that's easy to do, but let's kind of sketch a curve that goes from this point to this point. Well, it's going to stay above the ellipse, so it's going to kind of look like this. Understanding that we're curling back into the second quadrant of the XY plane, and we're also raising up a little bit. Now if the motion continues at that rate, as it will because of the sine and cosine functions, then in another equal time interval we're going to come around to this point. Now we will have our t squared in equal time intervals will increase by some unit and then by 3 times that unit, because of course t squared, if t goes from 0 to 1 to 2, t squared goes from 0 to 1 to 4. And without writing all that out, we see we're going to go from this point to this point. And to do that, we're going to have to continue going along here and moving around, but we're going to rise faster and faster so that our graph might look something like this. If we go another time interval, we're going to be up to 9 times the height of our first new plane, and we're going to be following something very much like an elliptical helix, but we're going up at faster and faster pace so that the coils of this helix are spread out more and more and more as we move up.